Module 3, Lesson 18, Distance on the Coordinate Plane. Looking at our big learning targets here, I can solve real-world and mathematical problems using the coordinate plane. I can use coordinates and absolute value to find the distance between points on the coordinate plane. This lesson is about distance. I can compute the length of horizontal and vertical line segments, so parts of lines, on the coordinate plane by counting units and using absolute value. Four friends are touring on motorcycles. They come to an intersection of two roads. The road they are on continues straight and the other is perpendicular to it. The sign at the intersection shows the distances to several towns. Draw a map or diagram of the roads and use it and the information on the sign to answer the following questions. What is the distance between Albertsville and Dewey Falls? What is the distance between Blossville and Cheyenne? On the coordinate plane, what represents the intersection of the two roads? So pause here for a moment, draw a little map, and answer these questions. And when you're finished, go ahead and unpause and you can take a look at my little map and compare yours with mine. So I have an intersection of two roads. It says if I go left 8 miles, then I wind up at Albertsville. If it says I go straight ahead 3 miles, I end up at Blossville. It says if I go straight ahead 12 miles, I end up at Cheyenne. And it says if I go right and go 6 miles, I get to go to Dewey Falls. So what is the distance between Albertsville and Dewey Falls? So I'm here, and if I want to go straight to Dewey Falls, I would have to go 6 miles. If I want to go to Albertsville, that would be 8 miles. So the distance between the two of them is the 8 miles plus the 6 miles for a total of 14 miles. So I have counted from Albertsville to where I am, which is 8 miles, and then I counted from where I am to Deweysville, which was 6 more miles for a total of 14. Now the distance between Blossville and Cheyenne, I would go 3 miles to Blossville, but then I have to keep going to get to Cheyenne, and if I look at this kind of like a tape diagram, it's 3 miles to Blossville, but Cheyenne is a total of 12, then I can figure out I need 9 more to get from Blossville to Cheyenne. So the distance between Blossville and Cheyenne is 9 miles. I want you to notice that on the first question I used addition to solve. On the second question I used subtraction. On the coordinate plane, what represents the intersection of the two roads? Where these two roads meet, what do we call that on the coordinate plane? Starts with no. Origin. Alright, so now we're going to use some of what we observed in that example and do a little bit of thinking and solve some problems. So the first thing we are going to consider is what if we have -4 and 0 and 5 and 0. So I've got -4, 0, and 5, 0. Now one thing I notice is that they share a y-coordinate. What do the ordered pairs have in common? They have a y-coordinate in common. They share that. Now if they share a y-coordinate, that means that they're on the x-axis. They're not above the x-axis, they're not below the x-axis. That means that these 2 points are on the x-axis. They're just in different spots on the x-axis. Both of their y-coordinates are 0, so each point lies on the x-axis, which is the horizontal number line. Okay. So how do we find the distance between two numbers on the number line? Well, if we stop and think about this for a second, I have 0, I've got one that's at -4, and I've got one that's at 5. If I want to find the distance between the two numbers, I can take the absolute value, or the distance of 0 to 5, and I can find the distance between -4 and 0, which is 4, and I can combine those together. So what I'm doing is taking the absolute value of -4, and I am adding it to the absolute value of 5. The distance from 0, remember we did that whole thing about absolute value is the distance from 0. If I can find their distances from 0 and combine them, then I can know their distance apart. They are 9 units apart. Now something that's important that I would like to point out here. These 2 points, this -4 and this 5, are on opposite sides of the y-axis. How do I know they're on opposite sides of the y-axis? Because one is negative and one is positive. So I have 2 points that are on opposite sides of the y-axis. I can take the absolute values and add them together to find the distance. Count from 1 and get to 0, and count on to get to the other number. So we calculate the absolute values of the numbers, which told us how far the numbers were from 0. If the numbers were located on opposite sides of 0, then we add the absolute values together. So I'm finding the absolute values, and because they're on opposite sides of the axis, I can combine them. If the numbers are located on the same side of 0, then I'm not going to add them together. I'm going to find the difference of the absolute values. So it's find absolute value. If they're on the same side of the axis, find the difference. If they're on different sides of the axis, I will add them together. So we're going to use the same method to find the distance between -4, 0 and 5, 0. So they're on opposite sides of the axis, so I need to find the absolute value. -4, absolute value is 4. 5, absolute value is 5. Opposite sides of the axis, combine them together. I have a distance of 9 units. Okay, I've said it like 3 different times, 3 different ways. So here we have 0, -6, and 0, -11. Now what do they have in common? Okay, they share an x-coordinate, which means they are on the y-axis. If they share an x-coordinate, and that x-coordinate is 0, then they are on the y-axis. If I look at these second numbers, they're both negative, which means they're on the same side of the x-axis. So they're on the y-axis, and they're on the same side of the x-axis. So they're not going to go across the x-axis. So what does that mean about the line segment's location? The x-coordinates of both endpoints are 0, so the points lie on the y-axis. I said that. The vertical number line. If its endpoints lie on a vertical number line, then the line segment itself must also lie on the vertical line. Okay, great. So we're going to find the length. Well, we're not worried about this part. We know that they're on the same vertical line. The question is, how far apart are they? Now they are on the same side of the x-axis. So I'll need their absolute values, I know that much. So I've got 6 and I've got 11. The question is, do I add them together or do I find the difference? Remember, I add them together if they're on different sides of the axis. Now these are both negatives, which means they're on the same side of the axis. So I'm not going to add them. Because they're on the same side of the axis, I'm going to find the difference. 11 minus 6 tells me that they are 5 units apart, a distance of 5. Here we go. We're going to look at negative 3, 3 and negative 3, negative 5. What do the endpoints, which are represented by the ordered pairs, have in common? Well, they both share this negative 3. So they are both on the same x-coordinate. And if I quickly do a little visualizing here, but it's negative 3. Quickly do a little bit of visualizing. Here's the negative 3. One of them is going to go up, the other one's going to go down. So they're sharing this vertical line together. They're both on this vertical line that goes through x's negative 3. If I look at the y-coordinates, I see I've got one that's positive and one that's negative, which means they're going to go across the axis. They're going to go across the x-axis here. So they're on opposite sides. One of them is coming up, one of them is coming down. So if I'm thinking about finding the distance between these points, I'm not going to worry about this part because that tells me that they're on the same line. I need the absolute values of each one. How far are they from 0? 3 and 5. Now I need to stop and ask myself here, am I subtracting or am I adding? Well, they're on opposite sides of the axis. I have opposite signs. I had a positive number, I had a negative number. If they're opposite sides of the axis, I have to count to the axis and then count some more from the axis. I'm going to add these together. And I'm going to find that they are 8 units apart. I've already talked through all of that. All right, so here we go. We've got some exercises, A, B, C, D, and E, and we are going to practice exactly what I've been modeling for you. We've got 2 points, and we want to find the length of the line segments. And we're going to explain how we figured out if the line segment is horizontal or if it's vertical. All right, well, looking at them, I see they both share an x-coordinate. If they share an x-coordinate, that means they are a vertical line. And I'm going to show you how I came up with that. They're both at negative 3, and they're both going up from negative 3. So I would have a vertical line. Okay, now length. I need to find the length. So I'm not paying attention to the negative 3 because that just tells me where their line is at. The 9 and 4 tells me how far apart the points are. So I need their absolute values, 9 and 4. And I need to ask myself, am I adding or am I subtracting? If they are on the same side of the axis, if they aren't across an axis from each other, I will subtract. If they're across an axis from each other, I will add them together. These two are on the same side of an axis, here and here. They're both above the x-axis. So I'm going to find the difference. 9 minus 4 gives me a distance of 5 units between the 2 points. I'll try and put that explanation back up there. So both endpoints have coordinates, x-coordinates of negative 3, so the points lie on a vertical line that passes through negative 3 on the x-axis. The absolute value of 4 is 4, and the absolute value of 9 is 9, and the numbers are on the same side of 0. They're on the same side of that x-axis. So by subtraction, 9 minus 4 equals 5, I can find the length of the line segment with endpoints negative 3, 4 and negative 3, 9 is 5 units. All right, here's exercise B. Go ahead, pause the video and try this on your own, then unpause the video and compare your thinking with my thinking. All right, so they are sharing this y coordinate. And if they share a y coordinate, that means that they are a horizontal line because they're both passing through negative 2 on the y-axis. So I have horizontal line. Not only is it a horizontal line, it is 2 units below the x-axis. So not only do I have a horizontal line, I know exactly where that horizontal line is. It's 2 units below where the x-axis is. Now if I want to find the distance, now that I found where my line is, I need to look at these other coordinates. Now one of them's a positive number and one of them's a negative number. And because they have opposite signs, that means that they are going to be across an axis from each other. One of them is going to be in a positive section and one of them is going to be in a negative section. So they're across an axis from each other. So I need to find the absolute value of 2 and the absolute value of negative 8. And I am going to add them together because they are across an axis. One of these is at 2 over here. One of them is at negative 8 over here. So if I want to find how far apart they are, I need to add the 8 to the 2 and find out that they are 10 units from each other, 10 units apart. Both endpoints have y coordinates of negative 2, so the points lie on a horizontal line that passes through negative 2 on the y-axis. The absolute value of 2 is 2, the absolute value of negative 8 is 8. The numbers are on opposite sides of 0. They were on opposite sides of the y. One of them was over here at negative 8, one of them was over here at 2. So the absolute values must be added by addition. 8 plus 2 is 10, so the length of the line segment with endpoints 2, negative 2, and negative 8, negative 2 is 10 units. All right, let's take a look at exercise C. Go ahead, pause the video, think your way through the problem, and then compare your thinking with my thinking. All right, they are comparing this first coordinate, sharing this first coordinate of negative 6. That is the x-coordinate, and since they share an x-coordinate, that means I have a vertical line. Because they're both at negative 6, one of them's going down at negative 6, one of them's going up, I have this vertical line, and I know that this vertical line is 6 units from the y-axis. Because they're negative 6. That's 6 units right there. Okay, so now that I know that I've got a vertical line and that both points are on the vertical line, I need to find out how far apart the 2 points are. So I need absolute value. And the question is, am I going to add or subtract? If I look at the locations, this one is in the negative, so it's below the 0. This is in the positive, so it's above the 0. So they're across an axis from each other. If they're across an axis from each other, I need to take the distance they are from the axis and I need to combine those together to find a total of 7 units. These points are 7 units apart. Both endpoints have x-coordinates of negative 6, so the points lie on a vertical line. The absolute value of -6 is 6, and the absolute value of 1 is 1. The numbers are on opposite sides of 0, so the absolute values must be added. So we do addition. 6 plus 1 is 7. The length of the line segment within points -6, -6, and -6, 1 is 7 units. All right, let's take a look at D. Once again, pause the video, give this a try yourself, and then compare your thinking with my thinking. So looking at these, I see that they share a second coordinate, which means they share a y coordinate, which means this is a horizontal line. Because they are both going through 4 on the y-axis. So it's a horizontal line, and it's 4 units above the x. So I now know that I've got a horizontal line. The question is, how far apart are these points? I've got a -9, and I've got a -4. Now I instantly notice that they are both below 0. So they're going to be on the same side of the y-axis. So when I find their absolute values, 9 and 4, because they're on the same side of an axis, I'm going to subtract. 9 minus 4 is 5 units apart. Both endpoints have y coordinates of 4, so the points lie on a horizontal line. Absolute value of -9 is 9, -4 is 4. The numbers are on the same side of 0. So by subtraction, 9 minus 4 is 5. I can find the length of the line segment is 5 units. One more to look at. Interesting. So I have an x-coordinate of 0. I'm not moving any left, I'm not moving any right. So this is a vertical line because they share an x-coordinate. And the vertical line is the y-axis. It's not to the left of the y, it's not to the right of the y, it is y. Alright, so now that I know I've got a vertical line, I need to find out how far apart these points are. I've got a -11 and I've got an 8. I noticed that this was negative and this was positive, so they are going to be on opposite sides of the axis. They're on opposite sides of 0. So I'll find the absolute value, 11 and 8, and because they're on opposite sides, I will add them together and get a total of 19 units. Their distance is 19 units. Both endpoints have x-coordinates of 0, so the points lie on the y-axis, which is a vertical line. Absolute value of each, 11 and 8. Numbers are on opposite sides of 0, so we'll add, and we can find by addition that 11 plus 8 equals 19. The length of the line segment is 19 units. So why is it possible for us to find the length of a horizontal or vertical line segment even if it's not on the x or y axis? Pause and think about that for a minute. How can we do that even though they're not on the number line? When we say on the x-axis, we have this beautiful little number line here. Well, how can I find the length of a line up here that's not on the x-axis? Well, a line can still be a horizontal or vertical line even if it's not on the x or y axis. These aren't the only two horizontal and vertical lines in existence. There are lots and lots and lots of vertical lines that are out there. And there are lots and lots of horizontal lines that are out there. So we can use the same strategy to find their distance. We use those absolute values. Can you think of a real-world situation where this might be useful? Well, how about finding distance on a map? We did that right clear back at the beginning of the lesson. So to find the distance between points that lie on the same horizontal line or on the same vertical line, we can use the same strategy that we use to find distance between points on the number line. We're using absolute value. We just have to decide, are we going to add those absolute values or are we going to subtract? Find the difference of those absolute values. So hopefully you're feeling pretty good about being able to compute the length of a horizontal and vertical line segment on the coordinate plane by counting units and using absolute value. I hope you noticed that I was drawing a lot of just little coordinate planes and using brackets to help me see what I needed to do with numbers. Never be afraid to take a moment and sketch a little picture to help you solve problems. Alright, solving real-world mathematical problems using the coordinate plane, and we are using coordinates and absolute value. Boy, we hit that one really hard in this lesson to find the distance between points on the coordinate plane. That concludes Module 3, Lesson 18. Make sure you complete your problem set, your exit ticket, and if you need help, make sure you reach out to your teacher.